All right, great. Okay, so hi, I'm Jake. I'm American. I'm from Philadelphia. Go to McGill University, which is up in Canada, in Montreal. And my project this summer for InterMine, I titled it InterMine NLP. So that's Natural Query Translation for InterMine. So kind of broad overview. We've got tools like Query Builder and Blue Jeans, stuff for allowing regular users of the database to interact, build up complex queries in a graphical manner. But there's still some underlying knowledge of kind of the schema of the database that's necessary to build a query that way. And so this project aimed to determine whether we can use some kind of natural language interface, something like maybe you're familiar with Wolfram Alpha and its query search capabilities, something probably a little different from Google search, something that's kind of more of a question answering system than a search engine. So some examples of like kind of maybe simple queries that we could try to give responses for, something like which genes are named XYZ. A more complex construction, which maps a little more difficulty onto the database, would be something like show me genes related to Alzheimer's in X chromosome. So if you kind of look at just looking at the schema of the database, you realize that you can write kind of custom rules to answer questions like that, but it's a much more complex sort of question. It doesn't map super linearly into a simple query. Okay, so I'll go over the kind of steps I went through in determining, analyzing how this would work. So started with some background research, read a couple papers. I hadn't had any formal NLP training before. Sorry, hold on. You guys can still see me, right? Everything sounds good? I should check.
It looks good. Oh, we
Okay.
don't have the screen anymore though. Oh, there we go. We do
Is
now.
it bad?
Yeah, we're back.
Okay, sorry. Yeah, so read a couple background research papers. Like I said, I haven't taken a natural language processing course before. I'd had a little bit of background in machine learning and like basic artificial intelligence. So that was super interesting. Basically, what I learned is that for the last 20 to 30 years, most of the kind of advances in natural language processing have been on the machine learning and statistical models side of things, which is great and which gives you really powerful tools for like analyzing sentiment and extracting meaning from English or whatever language have you. Problem is that it requires a massive training data set, and these queries are going to be fairly specific. Their language is going to be fairly specific to genomics and specific to kind of the database in question. And so after a little digging around, I realized that we don't have access to a giant training data set for privacy reasons. We can't just like dig through logs of queries that have gone into InterMine databases. So I realized that probably a more realistic approach would be something a little bit more old school, which is kind of creating a grammar in order to parse the language, similar to how you would parse compiled programming language. And I did have some background with that. I've taken graduate level compilers course, so I thought, I think I can hack something together that'll work pretty well. And so this was a really interesting learning process. I'll get into step 2. So I started building kind of some of the background helper functions that we're going to interact with the database, pull relevant model information in. I should mention that this is a project that was done in Clojure. I think specifically in the project requirements, Clojure was listed. I'm not exactly sure why, but anyway, I happen to have some background in that language. So yeah, I got started kind of on this random query generation. So I wanted to generate random queries, and then I created a survey for InterMine members that they could kind of try to translate these random path queries into something that a human might have written. So that was both to see if maybe I could collect enough data to do some kind of statistical NLP, but really the main goal was to get a test set that I could use to later build up a grammar and test out test its performance essentially. Okay, so as far as the progress I made this summer, I've got a couple code snippets here that maybe don't mean too much to you, but essentially I built this little pipeline. There's about 5, I think on the next slide I have a diagram of the pipeline, but it's a 5 or 6 step process that takes you from your input English text into its best guess at a path query. So on the right over here, this is a screenshot of a little snippet of the grammar definition. So if you have any background in compilers, you might sort of know what you're looking at. It's a set of productions where you define so a constraint can be either a value or a path followed by exists. So that would be like a null check. So there's a lot of different ways that you can construct a constraint, and then further down in the file, all these different terms are defined themselves eventually in terms of actual English words. And then the trick is that this grammar is combined with a grammar which is generated from the actual database model. So it goes in, it pulls down your database model, it scans for your different class and feature names, and it generates like a bottom level of the grammar. So down here, I've just got a little screenshot, which I'll cover in the next slide. So here's kind of the outline. I'm probably close to my 5 minutes.
Yeah, if you could try and wrap up, that would be great. Thanks.
Okay, so all right, here's the basic pipeline. So your raw text comes in, show me genes with length under 2000. Lemmatizer, it kind of gets rid of your plurals. It reduces words into their infinitive form. We do some fuzzy matching. The word gene looks like the class name gene, so we replace that. Then that gets fed into this big parser, which is the static parser I described earlier. That spits out this big giant parse tree. I run some transformations on that tree to kind of get it down to a more minimal size that kind of maps directly onto a query that is then it's attempted to translate into a query, which can then be sent over to queried against a database using a web API. What are the next steps? I'm not going to go through all of these, but essentially I want to add some more test coverage. There's some small improvements that I think could make things a lot more accurate. Adding some features. Right now I don't support handling sorting or referencing list constraints. Yeah, you can read this on your own time if you want. But that's about it. Sorry, haven't really rehearsed that.
No, thank you very much. Great job.
Yes, I apologize. I've got a flight to catch, so I'm a little bit fuzzy. Do I have to click? I guess I click stop sharing.
Yeah, looks good. Looks good. Cool. So does anyone have any questions for Jake?
Oh, this is very cool. That's neat work.
Thank you.
It's shame there wasn't more time to do more.
Yeah, exactly. Well, I've got a couple more weeks until school starts. I've got a couple commits in mind.
That's a really good choice of your use of time. We applaud that.
Just
Thank
for
you.
context, that's Gus with my boss, so he's very excited.